In this video, we're going to talk about Newton's first law. And Newton's first law states that an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction. Unless acted upon by an unbalanced force. Okay, so I want to take a moment to go through what this statement is saying because there's a lot of things going on here. First, I want to talk about the at rest. So there's two situations. One is when objects are moving, and the other is when an object is at rest. So it's saying that if object is at rest, not moving, it's going to stay at rest. Okay, so that's the first part of it. The second part is talking about an object in motion. So if an object is in motion, it's going to stay in motion, okay? And it's very specific here. Same speed in the same direction. Okay, so the same speed, same direction, we have a name for that. We call that constant velocity. So this part right here is referred to as constant velocity. Okay. And then it says unless, so that's going to happen unless, okay? So these two, it's conditional. If it's at rest, it's going to stay at rest. If it's in motion, it'll stay in motion at constant velocity, okay? And it's conditional upon this right here, which is a unbalanced force. So unbalanced force. Okay. We can also refer to this as a net force. Okay. So net force, not zero. There's unbalanced. So a net force is when there is the forces are not balanced. One of the forces is bigger, or there's not a force balancing the force there. Okay. So next, we want to talk about this idea of inertia. So you'll hear this term inertia when you're studying Newton's first law. And this is kind of just describing the property of objects to resist a change in motion. Okay, so that is consistent with what we said up here, which is that if it's at rest, it's going to resist change. It's going to want to stay at rest. But also if an object in motion, it's going to want to resist change. It's going to want to continue in the same motion. Okay. So here's an example. Here's a thought experiment. So I have a ramp here. And I have a ball. Okay. And if you release this ball is going to go down, it's going to go across, and it's going to go back up. Okay. And assuming no friction, the ball is going to roll back up on the other side. Okay. And if we were to make the ramp on the right-hand side at a smaller angle, what we find is that the ball will roll farther. But you'll find, even though the ball rolls farther, that the height of the ball stays the same. So the height of here, it rolls up back up to the same height. Over here, it rolls back up to the same height. Okay. So Galileo did this experiment. And what he concluded was that, let's say if we were to keep this flat, okay, so no ramp on this side, just as a thought experiment, he realized that if this was flat, that this ball would continue rolling and rolling and rolling and rolling, because there's nothing to bring it back to that height, because it seems like no matter what angle he set the ramp at, it would always roll back up to the same height. But if there's no height, then this would just continue rolling and rolling to the right. Okay, so if you were in space and you threw a ball or rock, okay, or a ball in space, what would happen is that the ball would continue moving in a straight line at constant speed, and it would continue moving forever, okay, unless there's something that gets in its way and stops it. And the tendency of objects to continue doing what they're already doing, we call that inertia. Okay, so think of this, when you think of inertia, think of property. Okay, so it's just property of objects to resist a change in motion. If it's not moving, it's going to resist moving. If it's already moving, it's going to resist speeding up or slowing down. Okay. So let's say that you had a string and a ball, and you were to spin it overhead. Okay, so this is a top view. This is like a drone view, like you're looking down and you're swinging this ball on a string, and it's going around. Okay, and let's say it's swinging, 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 and then at this point, the string rips. Okay, the question is, in which direction will this ball move? Will it move in this direction? Okay, we'll call this A. Will it move in this direction? We'll call this B. Will it move in this direction? C. Will it move in this direction? D. Okay, which way will it move? Okay, so let's follow the direction. So this ball is going in this direction. Okay, it's going this direction, this direction, this direction, and this direction, this direction. Okay, the reason it was going in a circle is because there is a string here pulling it towards the center. But without that string, once it's ripped, it's going to want to go straight. Okay, because this idea of inertia, property of objects resist change in motion. So at this point, it's pointing this direction, so it's going to want to keep moving in a straight line in that direction.